All right, I'm going to do my explanation for the problem I solved via video because I'm just so into doing videos these days. But the problem that I chose to do is the Fibonacci Cycles problem on Caddis. It's got a difficulty rating of 4.3. It's actually not that difficult if if you remember a few things. So the idea is that you're looking at the Fibonacci sequence, f of n equals f of n minus 1 plus f of n minus 2, where both f of 0 and f of 1 are 1. But what we want to do is look at that sequence modulo some integer k, and then find the index or the n value of the first number that is repeated. Okay, so let's talk about different pieces here about how this is going to work. The first thing that we have to take into account is, let's use black instead of green, is don't do recursion. Okay, we know that a recursive solution to the Fibonacci sequence is possible, but it's also really, really slow. So we're going to do dynamic programming instead. And the dynamic programming situation or solution for this is super easy. And then the second one is that we have to do this with modular mathematics or modulo math because the normal Fibonacci sequence gets large really quickly. So we couldn't, if you look at the problem specification, n might be as large as 1,000, and that's going to be too big to really work with reliably. So what we can rely on is that f of n mod k is equal to f of n minus 1 mod k plus f of n minus 2 mod k, and then we can take the whole critter mod k. All right? And if you wanted to convince yourself of that, like I did, you can use a little spreadsheet. So here's my values of n, here's my values of the nth Fibonacci number, and here's f of n mod whatever value here. And then this column is that formula that I just drew. So if we do our math this way, then we don't have to worry about storing large values because it never gets larger than 999. And then the last bit is how do I keep track of which value have I seen before? And so my strategy is going to be to store an array of integers that will represent the first time I've seen each of the values in the sequence. So I'll initialize all the values in here to -1. And then when the first time I find a value f of n mod k, if that spot is still -1, then I'll just put in the value of n that produced that, so maybe 5, whatever it is. And then the next time, if I check in that spot and I see it's not a -1, then I just have to output that number and I'm done. I can move on to my next case. So this is a Java version of that particular program. We read in our Q, which is our number of cases. Then I'm going to just allocate this scene array as an array of integers before I get into processing the cases, because I'll just reuse that memory. Then for each case, read the value of k, set the values that are appropriate, just 0 through k minus 1 to -1. Those are my scene values, and then set up my Fibonacci sequence mod k. So f0 is 1, f of 1 is 1, f of 2 isn't determined yet, and n is equal to 2. That's my subscript because he doesn't look at zeros and ones, f0 and f1. So we calculate our next value using the modulo arithmetic that we looked at on the whiteboard. Check to see if I've seen it. So if the value at that location, the array is not -1, I've seen it before, output that value, that gives me the index that first produced that value mod k, then break and go on to the next case. Otherwise, say, all right, this is the first time I've seen this value, so I'm going to record n. That's the n that produced that value. And then this is the dynamic programming part. I just sort of slide F0 and F1 up, and the next time I do F sub 2, it's the next value in the Fibonacci sequence. Increment n by 1. All right, so that's the solution for that. And then if we look at our statistics in Java, I'm on 6th place in terms of time complexity, and I could probably bring that down to much quicker if I changed from using a scanner, but it's not really worth it. In C++, everybody's a 0, 0, so I did a C++ solution. Everybody takes no time. And then in Python 3, I did a Python solution 7th there. So there we go. That is the key to solving the Fibonacci cycles solution or problem, is to use that modular arithmetic.